This is the video for section 11.3, Arcs and Central Angles. Please follow along with your video worksheet. The first section has all of the terms, definitions, and diagrams that I will be using, and the second section has all of the example problems that I will be showing you. Please fill in the worksheet as you watch the video. Let's begin. A semicircle is an arc that has measure equal to 180 degrees. Now an arc is going to be measured along a circle. And an arc, just like a segment, will have two endpoints. And in this case, our semicircle is drawn in light blue here. It has endpoints A and B. Now, this arc happens to go through point X, so I'm going to name X in the middle, and then I'm going to draw an arc symbol above. So this is arc AXB, our semicircle. Now when we name semicircles, we must use three letters. Now this arc AXB, our semicircle, can also be named another way. We can start with the B endpoint, end with the A endpoint, and also still going through X with our arc symbol. So arc BXA is another way to name this same arc. Now the measure of a semicircle, we write M of arc AXB, for example, is going to be 180 degrees. So the measure of arc AXB is 180 degrees. Moving on, a minor arc has measure less than 180 degrees. So here is an example of a minor arc. Now a minor arc is going to be smaller than a semicircle, which gives it a measure that is between 0 and 180 degrees. So this purple arc that I just gave you, let's just say, for example, this one has measure 102 degrees. It is between 0 and 180 degrees, so it is called a minor arc. Now this minor arc has endpoints C and D. Now minor arcs, we're only going to use two letters to describe. So this minor arc is called arc CD. Now, just like with a semicircle, we can switch around the letters, and we could call this same purple arc arc DC. Now in either case, the measure of this arc, measure of arc CD, is going to be 102 degrees. Now there is another minor arc in this diagram. It is being shown to you in green now, and that minor arc is called arc CE, or arc EC if I switch around the letters. Okay, now this one has measure also less than 180 degrees. In order to figure it out, I'm going to take 180, which is the semicircle, minus 102, and that gives me 78 degrees. Again, I found that by taking 180, the measure of a semicircle, minus the measure of arc CD, which is 102 degrees, and that gives me 78 degrees, which is the measure of arc CE. A major arc has measure greater than 180 degrees. So I'm going to start by shading in arc CD, which we said before was 102 degrees. Now if I go from C to D the long ways rather than the short ways, I'm going to be going around this way. And this blue arc that I just showed you is called a major arc. Now this major arc has endpoints C and D, just like the minor arc does, but we're going to denote this major arc with 3 letters rather than the 2 for the minor arc. So I start at C, go through E, and end up at D, so I'm going to write E in the middle and the arc symbol above. So major arcs, just like semicircles, must use 3 letters. Now, just like the other arcs that I've shown you, we can switch around the letters and start with the D, end with the C, and again still go through E, and arc DEC is still the blue major arc. Now, in order to find the measure of this major arc, the measure of arc CED, I am going to take the whole circle, which is 360 degrees, minus the 102 degrees of the purple minor arc, and that will give me the measure of arc CED, which is the measure of the major arc. So 360 minus 102 is going to be 258 degrees, and that's the measure of the blue major arc. A central angle is an angle whose vertex is at the center of a circle. So I'm going to be shading here our central angle. And this angle has, for example, 72 degrees as its measure. We're going to name this angle just like we named any other angle, with the angle symbol, vertex letter, which is O, in the middle, and then 1 letter from each of the 2 sides before and after the O. So this angle is angle FOG, or I could switch around the letters and say this is angle GOF. In any case, it is our central angle. Now, the arc that I'm shading now in blue is called our intercepted arc for this angle. So in this case, our intercepted arc is arc FG. It is a minor arc, so I'm going to be using 2 letters to describe it. And in this case, the measure of arc FG, the intercepted arc, is going to be equal to the measure of our central angle, angle FOG, which in this case is 72 degrees. So the measure of a central angle and the measure of its corresponding arc are equal. Moving on to our first example problem, we are given a diagram where AD, segment AD, is a diameter, and we are to list all of the minor arcs, major arcs, and semicircles that we see in this diagram. Now I'm going to be listing the minor arcs and major arcs in pairs. So the first minor arc that I see is arc AB right here. I use 2 letters because it is a minor arc. Now if I go from A to B the long way around the circle, I will be getting its major arc. So in this major arc, I'm going to start with A again, end up at B, and here's my arc symbol, but major arcs need 3 letters. So I am going through E and D. I can pick either E or D to go in the middle of my arc. So I'm just going to pick E. So arc AEB is the green one that you see, which is a major arc. Okay, our second example is going to be arc AE. Now arc AE is a minor arc because its measure is less than 180 degrees, or it's smaller than a semicircle, and its corresponding major arc goes around the long ways, which is arc A, B, E. Now we could also name that arc ADE. Our third minor arc goes from B to D, so I call that arc BD. And its corresponding major arc again goes from B to D the long way, going through A and E. So I'm going to start with B, I'm going to end with D because those are the endpoints of my major arc, and I go through A and E. I can put either one here in the middle. I'm going to put A, so arc BAD is my green major arc. My fourth minor arc is arc ED, and his corresponding major arc goes from E to D the long way. So I'm going to call that arc EAD. My last minor arc is one that people often miss. But arc BE here is also a minor arc because it is smaller than a semicircle and its measure has less than 180 degrees. I'm still going to call it arc BE with two letters because it is a minor arc. Going the long way around from B to E, I get its corresponding major arc, which is arc BDE. And those are all our minor and major arcs. As you can see, it makes it much easier to find, especially the major arcs, if I find these in pairs. Now our semicircles we find by looking at our diameter, segment AD, and we go from A to D around this way of the circle, and that gives me a semicircle, arc A, B, D, and remember we use three letters to describe semicircles. And if I want to go the other way around from A to D, I go this way, and that yellow semicircle is arc AED. Now as you can see, by switching just that center letter, it tells us we go around the semicircle one way or we go around the other semicircle. Example 2. Now in example 2, we have a diagram where some angles are given, and we're given that segment AD is a diameter, and we're asked to find the measures of a bunch of arcs and angles. So the first thing I'm going to notice is my diameter, which is segment AD right here, and all of the angles on one side of that diameter must add up to 180 degrees. So what I'm going to do to find x is take 180 minus 35 minus 65, and that gives me 80 degrees for my x. So I'm going to label it right in here as 80 degrees, and over here on my answer blank. The next thing I'm going to do is notice that all of my central angles in this picture have the same measures as their intercepted arcs. So my first one is arc AB. He has measure 35 degrees because his central angle has measure 35 degrees. And I go over on my answer blank, the measure of arc AB is 35 degrees. Likewise, the measure of arc BC is 65 degrees because his central angle has measure 65 degrees. So on our answer blank, the measure of arc BC is 65 degrees. The next thing is arc CD is going to have measure 80 degrees because his central angle has measure 80 degrees. Now they don't ask for this on the answer blanks, so I'm going to move on. The next is the measure of angle CFD. Now erasing this diameter for a moment, the measure of angle CFD, as you can see there in the yellow angle, we found as 80 degrees. Next is the measure of angle AFC. Angle AFC is shown here in yellow, which is just the 35 degrees and the 65 degrees right here added together. So 35 plus 65 is going to be 100 degrees, because 35 degrees plus 65 degrees is 100 degrees. Next, we're asked to find the measure of arc AED. Now, arc AED is right here, and that is going to be a semicircle, so its measure is 180 degrees. And the last arc we're asked to find is the measure of arc CDA. CDA is going to be right here, starting at C, going through D, and ending up at A. So I can find this by saying, well, arc CD has measure 80 degrees, and the rest of the yellow arc is a semicircle, and it has measure 180 degrees. So 80 plus 180 is 260 degrees. So that's the measure of arc CDA. Question 3 asks us to find x. Now, 6x minus 7 is a central angle, and 128 degrees is its intercepted arc. Now, central angles and their intercepted arcs have the exact same measure. So 6x minus 7 is equal to 128 degrees. Solving this algebra problem, I add 7 to both sides, getting 6x equals 135 degrees. Dividing both sides by 6 gives x equals 22.5 degrees. And don't be afraid here if you get a decimal answer, because you will have decimal answers for some of these angles, and that's totally fine. Question 4 gives us a diagram and says find x. Now it gives us a central angle which has measure x degrees, and its intercepted arc, which I'm showing you right now in light blue, is also going to have measure x degrees, because the measure of a central angle and the measure of its intercepted arc are going to be equal. Now, this major arc that I'm tracing now in green has measure 5x plus 12. Now if you look, the green arc and the blue arc together make an entire circle. So I can set up an algebra problem that says x, the blue arc, plus 5x plus 12, the green arc, equals 360 degrees, which is the number of degrees in an entire circle. Collecting my like terms gives 6x plus 12 equals 360 degrees. Subtracting 12 from both sides gives 6x equals 348 degrees. And dividing by 6 gives x equals 58 degrees. This concludes the video on section 11.3, central angles and corresponding arcs. Thanks for watching.